These are the frequently asked questions for homework for pre-calculus, and this would be for section 2-4, day 2 or 3 here. You have 29, 31, 45, 49, 51, 55 to 61, and 67. So what we have here is the first one being in exercises 27 to 30. Find the polynomial function with leading coefficient 2 that has the given degree and zeros. So what we really want to start off with in number 29 is the fact that we have the 3 zeros. So if we do this right, those 3 zeros will give us that third degree polynomial. So just kind of thinking in advance, the degree has to equal 3. I need my zeros to be 2, 1/2, and 3/2. Well, I think about those zeros and the fact that it comes from this x minus k format, so it must have been x minus 2 in order to get a 0 of 2. And then the x minus 1/2, we could certainly write it as x minus 1/2, but that's just kind of weird to work with all the way through. So instead, we could think they must have divided by 2, which means it had to be multiplying by 2. And they must have added 1, so that would mean that came from subtracting 1. And that gives it a much nicer look for our FOIL that we're going to need to do. Same thing with the 3/2. We could write x minus 3/2 and call it a day. But really, if we want this to work out nicely, to have those nice, well, non-fraction coefficients, then we would go ahead and say, all right, how did this get to be this way? They divided by 2, which means originally it was multiplying by 2. And then they added 3, which means originally it was subtracting 3. And then finally, since it said they want this to be a polynomial function, we should call this f of x. So let's get all of this and then see what happens. So the first thing we want to do is, I'm going to leave this x minus 2 all by itself, but I'm going to go ahead and do FOIL on the other 2. And so we would get, by doing FOIL on that, 2x squared, and then minus 6x minus 2x would be the two middle terms for a grand total of minus 8x. And then negative 1 times negative 3 would give us positive 3. Then we'd go back and distribute the x to everything. So x times 2x squared would be 2x cubed minus 8x squared plus 3x. Then we would distribute the negative 2 to everything, and that would give us negative 4x squared plus 16x minus 6. And then we would go ahead and combine any like terms that we see here. So this would be f of x equals 2x cubed minus 12x squared plus 19x minus 6. Now, to me, that's the best answer, but you know, there are so many different answers that would be correct for this one, because let's just assume you didn't care whether or not you had fractions for your coefficients. You could go ahead and FOIL all of that out. And one of the answers that you saw in the book decided, hey, we don't want to mess with 3/2. We're going to go ahead and write this one as 2x minus 3. But they made the decision to stick with the x minus 1/2. And that decision was probably based on the fact that 1/2 as a fraction is not horrible to work with. So their answer, when you look in the back of the book, will be a little bit different. Both answers are correct. Like I said, if we don't want any of our coefficients to be fractions, then this would be the best answer. Then, number 31 says, in exercises 31 and 32, use only algebraic methods. Find the cubic function with the given table of values, check with a grapher. Now, let's use logic here. What we're studying in this chapter is when you have the zeros, you can write a polynomial function. Now, the zeros are where we're crossing the x-axis, the x-intercepts. So at negative 4, 0, we have a 0. At 3, 0, and at 5, 0. Now notice I'm ignoring that 0, 180 for a second, because that's, well, it doesn't really have a lot to do with our first thought process, and our first thought process is, let's just get a polynomial that will cross at these 3 places. So we're going to call it f of x. And if we have a negative 4, that came from x plus 4 to get us that 0. If we have a 3, that came from x minus 3 to give us a 0. And if we have a 5, that came from x minus 5 to get a 0. Now, the book takes a shortcut method at this point, and I'm not going to do a shortcut method because shortcuts are not logical. Instead, what I'm going to do is I would go ahead and multiply this out like I would any other polynomial to see what I have. So in this case, we leave this x plus 4, and we would go ahead and do FOIL on the back 2 here. So x squared minus 5x minus 3x would be minus 8x plus 15. And then we would go ahead and distribute the x, and then distribute the 4. So that would give us x cubed minus 8x squared plus 15x plus 4x squared minus 32x plus 60. Now, I didn't obviously take you through each individual step because you guys are fully capable of that. Distributing the x through the second parentheses, distributing the 4. And then the volume was down. I just wanted to warn you about that because this is probably getting a little louder right now, so you'll want to turn down the volume. All right, so we have our x cubed, and then negative 8x squared plus 4x squared will give you negative 4x squared. We have 15x minus 32x for a negative 17x, and then we have the plus 60 in the back. Now, you should be saying to yourself, but Cedarholm, there was that one piece of information up there that we skipped earlier, and that is that we need to get 0, 180. Right now, if we put a 0 into this, we're going to get 60. So I think, well, what could I do to this function in order to get that 60 to be 180? And what we can do is we can multiply both sides by 3, and that will give us an equivalent function. So this will still be f of x because we're just building it. That's all we're doing. That 3, we know from the past, it doesn't have an x attached to it, so it's not going to affect our zeros whatsoever. But we would just go ahead and multiply this out and see what we get. So 3 times x cubed would be 3x cubed. 3 times negative 4x squared would be minus 12x squared. And then we have 3 times 17. So we go ahead and do the math on that one and get 51. And then we'd have our 3 times 60, which would be 180. So now this polynomial meets all the requirements that they had for problem 31. And if you check the answers in the back of the book, you're going to see, wait a minute, they didn't do any of this math. So let me take you to the shortcut that they used. The shortcut that they used was they said, all right, let's go back up here. What would we have right now for that last term if we multiplied all this out? Well, we would have 4 times negative 3, which is negative 12, and negative 12 times negative 5 would give us negative 60. And they said, okay, if I've got 60 back there now, and I want, oh, actually 2 negatives make it positive. I have 60 back there now, and I need it to be 180. Well, I just need to multiply everything by 3, and they stuck a 3 right in there. Again, that's a shortcut in thinking, and right now I would rather that you worked your way logically all the way through that problem to see why everything makes sense in the end. You know, that you're going to have the same zeros whether or not you multiply that by a 3 or not, but in order to get that 180, 0, 180 point, the y-intercept, you need to multiply the whole thing by 3. All right, next one up is 45. It says in exercises 45 to 48, use the upper and lower bound test to decide whether there could be real zeros for the function outside the window shown. If so, check the additional zeros. And really, these are the y's. I couldn't care less about the y's. The bounds are about the x's. Is that the last place that this is going to cross the x-axis? So what we have to do is use synthetic to see what the signs are when we get our result. So we have a 6x to the 4th, negative 11x to the 3rd, negative 7x squared, 8x minus 34. And I'm trying to see whether or not negative 5 is going to be a lower bound. If it's a lower bound, the signs that I get when I do the synthetic division should alternate. Positive, negative, etc. So we bring the 6 down, and we're outside the box, so we're going to multiply. That will give us negative 30. Inside the box, add. Outside the box, multiply. Negative 5 times negative 41 is 205. Inside the box, add. Negative 7 plus 205 would be 198. Outside the box, multiply. Negative 990. Inside the box, negative 982, we're adding. Negative 982 times negative 5, 4,910. And then the addition inside the box. And we notice positive, negative, positive, negative, positive. It's about the signs, not necessarily about the numbers that we get, although those are obviously important as to which ones will give us a positive or a negative result. But what we just saw here was the last line is alternating signs. So negative 5 is a lower bound. If that doesn't happen, it's not a lower bound, and there is another 0 to the left of negative 5, but it did happen, so we know that's it. Now we need to check the other end of that, which was 5, and 5 is on the high end, so that should be our upper bound. And how we're going to know that is by doing the synthetic again, but this time with a positive 5, and if all of the signs are non-negative, so 0 or positive, then we know we have an upper bound. So we bring the 6 down, we multiply by 5, and we get 30. Negative 11 plus 30 is going to give us 19. 19 times 5 will give us 95. Negative 7 plus 95 is 88. 88 times 5 is 440. Add 8 to it, you get 448. 448 times 5 is 2,200. And negative 34 plus 2,200 is 2,166. Those are all non-negative numbers. In fact, to be more specific, they are all positive numbers. That means this is an upper bound. So since all signs in the last step are positive, comma, 5 is an upper bound. And I have a sneaking suspicion that perhaps you just didn't get this far in class yet on the notes to do that one. All right, next one up, 49, says we want to find all the real zeros of the function, finding exact values whenever possible, identify each zero as rational or irrational. So first thing I did with number 49 was I went through and wrote the list of all the possibles. So with a 6 in the back, the factors of 6 will become our numerator, and then with a 2 in the front, the factors of 2 will become my denominator. And then I go through and do that division, so it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And now going back through, using the 2, it could be plus or minus 1/2. 2 divided by 2 would be plus or minus 1. I already have that written down. Plus or minus 3/2, and then 6 divided by 2 would be 3. So those are already listed. So now what I want to do is use my graphing calculator to narrow down the search. And I'm not going to waste your time on this one because you can see these pretty openly. You can see at least one of these really openly when you do this. You just use your table feature or use the second trace 0 feature, number 2. And the one that comes out nice is 1.5, which we can see from our list was a possible. It is 3/2. The other just looks kind of obnoxious at 1.4142136, negative 1.42136, etc. So if you don't recognize that other one, you don't have to, because we can do synthetic and get this down to where it will be easier for us to find those last zeros. So we're going to do synthetic with 3/2 with 2x cubed minus 3x squared negative 4x plus 6. And what I'm doing while I'm writing this down is I'm just double checking that they're in standard form and there's nothing missing. Otherwise I'd have to put a 0 in place for the coefficients. Bring the 2 down, multiply 2 times 3/2 and you get 3. Negative 3 plus 3 is 0. 0 times anything is 0. In the box we add and we get negative 4, and then we would take negative 4 times 3/2 and that would give us negative 6. And this is now guaranteed as a 0. We have verified. That's what it's called when we do synthetic and see that the remainder is 0. So that is one of our zeros, and rational versus irrational. Rational means ratio, which is a fraction. This is definitely a rational zero. Now, my job is to finish this up by figuring out what on earth are those last two, that 1.4 blah, 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 blah thing. Well, maybe you noticed it right away and said, hey, that's the square root of 2, but let's make sure we can find that. This is going to be what our remainder is, which was 0. This is our constant, this is our x term, and this is our x squared term. So right now, we're trying to find out, by solving, finding those zeros, where it's going to cross the x-axis. So we would go ahead and add 4 to both sides, divide by 2, and then take the square root of both sides, and of course we would get plus or minus the square root of 2. So those are the other two zeros. We now have all three of them, but this is definitely irrational. You cannot write the square root of 2 as a fraction. It doesn't stop. It doesn't have repetition. It doesn't have any way for us to write that. So these are the other two zeros, and they are irrational. Now, I'm going to have to do some erasing here because you had several of these, which again makes me think you just did not get this far in class. So number 51, we'll go through the possibles. There's a 6 in the back. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 are all the factors of 6. And in the front, this is just 1. So dividing any of those by 1 is just going to get us those back. And then we would grab our graphing calculator and we would check and see what it's giving us for zeros. And we see that we have this 2.7320508, and we have a negative 0.7320508, and a negative 3. Now, the first two obviously irrational. We're not going to start with those. We're going to go ahead and use that negative 3 synthetically, and we're going to verify that that really is a 0, because we punch stuff in wrong all the time. And remember, when you're in AP Calc, you're not going to get to use that graphing calculator to figure these things out. In fact, this would be considered an easier problem, just having 8 of them that we have to try synthetically. So let's bring the 1 down, multiply outside the box, add inside the box, multiply out, add inside, multiply out, and add. So good news, the negative 3 definitely is working. And obviously that can be written as a fraction. Negative 3, of course, would be negative 3 over 1, so that is a rational 0. But I'm interested in this, because that's going to get me my other 2. So we have remainder constant x, x squared, and I have this. First thing to think would be, hey, is this factorable? Well, I already know it's not, and that's because it's not rational. And if it's not rational, then I'm not going to be able to factor it. So next way to go is completing the square. We have x squared minus 2x. Let's move this 2 out of the way. It's a pretty easy completing the square problem, because if we take negative 2 and divide it by 2 and square it, we get 1, which is a super nice number to work with. And this will be x minus 1, the quantity squared, square root, both sides, x minus 1 equals plus or minus the square root of 3, and then add 1 to both sides. And there are the other two zeros, 1 plus the square root of 3 and 1 minus the square root of 3, which of course would be the other two really nasty decimals that we saw up there earlier. So these will both be irrational. Go after the nice ones. Use that synthetically to whittle this down so that you can get to the other zeros. I mean, that's what this is all about. When we're saying solving, we are finding the zeros, which means we are finding the x-intercepts. And if we don't recognize a nasty decimal answer as a fraction that just pops into our head, or a radical that pops into our head, well, then we've got to do some work. We have to figure out where that's coming from. All right, same type of thing for number 55. So with 55, our possibles, there's a 4, so plus or minus 1, plus or minus 2, plus or minus 4. That's not a bad list. But in the front we have a 2, so plus or minus 1, plus or minus 2. So let's see what our possibles really would be. Plus or minus 1, plus or minus 2, plus or minus 4, and that's by taking the numbers and dividing them by 1. And then we go back through and divide by 2, so plus or minus 1 over plus or minus 2 is plus or minus 1/2. 2 divided by 2 is 1, and 4 divided by 2 is 2, and those are already in the list. So we don't need to do anything more for those. You pop it in the calculator, and it appears that negative 1/2 and 4 are 2 of the rational zeros here. But again, we don't know that until we go ahead and do the synthetic and see that that remainder is 0. So 55 is in standard form. Get those coefficients down there. Don't forget to take the sign with. And then go ahead and do your synthetic. Bring down your leading term, leading coefficient of a 2. Multiply times negative 1/2, you get negative 1. Add together with that negative 7 and get negative 8. Negative 1/2 of negative 8 is positive 4. Negative 2 plus 4 is 2. Negative 1/2 of 2 is negative 1. Negative 7 and a negative 1 is negative 8. And then negative 1/2 of negative 8 is positive 4. And that one is verified. Negative 1/2 is, of course, rational. And it is one of the zeros. Now, because that worked, I do not have to start over testing the 4. If it doesn't work, yeah, then I have to go back and start at the beginning again. But it did work, so I'm going to continue on with these numbers. Bring down that leading coefficient of 2. Multiply outside the box, add inside the box, and just keep up that pattern. And yes, we see that 4 is also a rational zero. So now our job is to figure out what are those last 2 zeros. So this is remainder constant x squared. You write that down this time. And our remainder again was 0. So this is 2x squared plus 2 equals 0. And I would subtract 2 from both sides and realize probably right at this point there's going to be trouble. Because if we have to take the square root here, these are imaginary. So the other 2 zeros are plus or minus I. So this doesn't have any more rational or irrational zeros. These 2 are going to be imaginary down here. And they didn't ask about the imaginary ones, just the rational and irrational. But nice to know that we found them all. So that's 55. Again, notice each time I'm starting with that list of possibles, and that is because of AP Calc, where you're not allowed to use that graphing calculator. You know, you're just going to have to take the possibles and keep trying until you find some that work. Number 56 is the same type of problem. So let's get cracking on this one. Our last number, the number in the back there, are constant, plus or minus 1, plus or minus 2 for factors. In the front of 3, plus or minus 1, plus or minus 3. So that means our possibles are plus or minus 1 divided by 1, which is plus or minus 1, plus or minus 2 divided by 1, which is plus or minus 2. And then we go back through with 2 over 1, which is 2. And now we're going to start with the 3, so 1 over 3 plus or minus 1/3. And then 2 over 1, like I said, we already had that in the other one. So 2/3 would be the other possibility. Always the top divided by the bottom there. So there's our possibilities, and we go ahead and grab what appears to be rational here. And the rational zero that appears to show up when we graph this is 2/3. So what we need to do is do our synthetic with 2/3 and see what we get. So our 2/3 gives us a 3, a -2, a 3, a 1, and a -2. And then we go ahead and bring the 3 down, multiply, and add. Use your synthetic as always. And get your 0. When you're checking that graphing calculator to see your zeros, and you realize that the 2/3 is really the only nice one that you're going to see, you have to ask yourself, okay, what would I do at this point? Well, what we would do is say, here's remainder, here's constant, here's x squared, here's x to the 3rd. So 3x to the 3rd plus 3x plus 3 equals 0. And what can we do with that? Well, at this point, you guys can't do anything with that. And the reason is because we can't factor that other than pulling the 3 out of there, and that's not going to bring us any closer to getting the zeros. And that's because this is not a quadratic, this is a cubic. So at this point, what we would have to do is just use that second trace, number 2, 0 feature. And that gives us negative 0.6823 278. And so what we would do is just say, hey, we know this is irrational. That's kind of the best we can do, but we'll go ahead and we will round that to 3 decimal places and say, okay, there it is. You know, that's the best we can do at this point. We're not capable, don't have enough knowledge just yet to figure out exactly what that is. So we grab the graphing calculator. All right, now I'm pretty sure I'm done with this page. And on the next page, we've got a little word problem here that apparently was messing with your heads a little bit. The Sunspot Small Appliance Company determines that the supply function for their Evercurl hairdryer is S of P equals 6 plus 1/1000th P to the third, and that's demand function is D of P equals 80 minus 2/100ths P squared, where P is the price. Determine the price for which the supply equals the demand and the number of hairdryers corresponding to this equilibrium price. So we need to know when is 6 plus 0.001 P to the third equal to 80 minus 0.02 P squared. And we need to keep in mind that P is price, and what we get for our Y value in all of this is going to be how many hair dryers. So Y value, the outcome is our hair dryers. All right, what do we have to solve something like this? Well, that cubic is not going anywhere. Even if we move everything over to one side, this is not going to be something that we can factor and do by hand at this point. So what we would want to do is get this into the graphing calculator as y sub 1 and y sub 2 and get a window that will make sense for what it is we're trying to do. So we are into y equals here, and we're going to do 6 plus 0.001 x to the third, because the calculator couldn't care less whether or not we're giving it an x or we're giving it a p. It doesn't care. All right, now next one up was 80 minus 0.02, and that was x squared. All right, so we've got the 6 plus 1,000th x to the third, and we have 80 minus 200ths x squared. Next up is window. And we know that we have a price issue here. So I start thinking hair dryers. Can't be negative, so I'm going to start with 0. Boy, I don't know that I've ever seen a hair dryer that I would ever even think of purchasing that was above $60. I know they're out there, but for most people, a cutoff is kind of right around $40 for a hair dryer. And then our Y starting at 0. And then our max, I don't know how many hair dryers. I think I'm going to go with like 150 here for how many hair dryers we have. And we see the first function there, the first side of y sub 1, and then there comes y sub 2. And what we're looking for is that intersection. So second trace, number 5, let Blinky do his job, 1, 2, 3, entering. And there we are. So $36.27 with rounding, and 53.69617 hair dryers. Well, you can't have 53.6 blah 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 hair dryers. So price is $36.27, and the number of hair dryers. We'd probably go with about 54. About 54. So there is 57. And you had also asked for 58. 58 is done the same way. Again, if you're looking at something saying, hey, I don't remember doing that by hand, then yeah, it's because we didn't. So we have the same thing, supply and demand functions. They're just changing this to make it zoom lenses. So we're going to need 200 minus P plus 0.1234507 P to the fourth. And we're going to need that equal to 1,500 minus 0.0004 P cubed. And what we're looking for here again is P the price. So that is our X value. And then our outcome this time is going to be the number of lenses, because this is a zoom lens. So like I said, you probably could do this one anyway based on the last one that I just did. But if the calculator here is going to behave itself, I can go ahead and do this one for you. Kind of worried about all the zeros. It doesn't like repetition. Oh, yep, it didn't take that, did it? Gotta go back and put minus x in there. It did not take the x. So I guess this is a good exercise on how to insert. If you hit second, delete, then you can insert something into that position. So I'm going to move this over, and I want to insert my subtraction symbol there. So second insert, put the minus in there instead, and now it's being ornery. And it's not letting me insert. Okay, so I'll start over. 200. And try again. Minus, there it goes, x plus 0.1, 2, 3, 4, 5, 7x to the 4th. All right, gotta quit telling it it's ornery because then it gets ornery for me on purpose. All right, the next side was 1500 minus, nope, didn't take the zeros. And then we have 0.1, 2, 3 zeros, 4, x to the, and this one was to the 3rd power. Didn't take the power. To the, there we go, 3rd power. All right, so 200 minus x plus 0.000007 x to the 4th, and then we have 1500 minus 0.0004 x cubed. Let's see, these were lenses. Lenses are going to cost a little more, so let's go into the window. Maybe $200 for a lens. Oh boy. Let's just try that. Let's hit graph and see if we can see them. All right, and I could see the calculator working like crazy. There it is. But notice we're not seeing the other one. So that tells me I need to go increase my y values. So now I think about what I had for y values, and the y values were going to be the number of lenses. And if you look at the second equation, they had 1500 minus something. So I'm going to try 1500. And again, you could always try zoom 0, zoom fit, if you're not able to get the window to behave like it should. But boy, does this color calculator take a long time to get us that nice graph. All right, there it is. So second, trace, number 5, enter, enter, enter. And there it is. So $106.99. And it looks like we'd have to sell a little bit more than 1,010 lenses. Be really tempted. In fact, I think I'm going to round that up to 1,011 lenses because you can't have a portion of a lens. So $106.99 is the price. And then 1,011 lenses. Right there. So those two, kind of strange how they're stuck in there, but they really are just all calculator. All right, 59 and 60. This is another one where I think you just didn't get far enough in the notes. So we have x to the 40th minus 3, and they want to divide that by x plus 1. So the remainder theorem says if we just figure out what k is here, and in this one it had to be k equals -1, we can put that in for x, and that will give us the output that we want. So instead of doing this synthetically, because that would really be a problem, you have x to the 40th, you don't have an x to the 39th, an x to the 38th, you'd have zeros all over the planet. Instead, you just think, hey, negative 1 to the 40th, anything to the 40th, that's going to be positive, and 1 to anything is 1. Answer's negative 2. Boom, done. So again, you know, we just think logically here. How am I going to make this work? So 60, this one, x to the 63rd minus 17 when it's divided by x minus 1. Well, that means k is positive 1. So 1 to the 63rd minus 17 is 1 minus 17, which is just negative 16. So yeah, by all means, don't do those two synthetically. Yeah. All right, you need to think, hey, if I'm working on something for 5 minutes that looks like it's supposed to be pretty basic, I have gone about this the wrong way. Number 61, we are letting f of x equal that monstrous polynomial that we see up there. And it says use the upper bound and lower bound test to prove that all of the real zeros of f lie on the interval of negative 5, 4, which I know you can do now since I went ahead and did the one earlier, but I'll just go ahead and say, okay, negative 5, if that's the lower bound, and 4th, 3rd, 2nd, 1st, 0 power, it is in standard form, so grab those coefficients and do the synthetic. And if this is the lower bound, we should see an oscillation of positive, negative as we go through. So bring down the leading coefficient, multiply times negative 5, add that to 2, multiply negative 3 times negative 5, get 15, add that to negative 11. Negative 5 times 4 is negative 20, so now we have negative 33, and we multiply that by negative 5, and we get 165, and we add that and get 203. And we can see positive, negative, positive, negative, positive. So the last line has alternating signs. So negative 5 is a lower bound. That's what lower bounds, that's what we're looking for every time, alternating signs. Now we want to check for that upper bound, and the upper bound is a 4. So we're going to start over, and we're going to use the 1, the 2, the negative 11, the negative 13, and the 38. And we're going to check this little bugger. Bring down the 1, multiply times 4, you get 4. Inside the box add, and you get 6. Then we have 24, and we add that to negative 11 and get 13. Multiply that by 4 and get 52. Negative 13 and 52 is 39. 4 times 39 is 156. Add that to 38 and we get 194. The numbers are important just because what they do is they lead us to the signs that we can see here. And we can see that every single one of these is positive. And again, all it has to be is non-negative. So zeros and positives are good. But in this one, we can say the last line is all positive signs. So 4 is an upper bound. That's what we were looking for. We were trying to make sure that we could see those. All right, now, next part to this for B is to find all of the rational zeros of F. So what we would do is we would go ahead and start by making that list of possibles. And that's going to be all the factors of 38, plus or minus 1, plus or minus 2. You go keep working on it, and you see the only other thing that's going to happen there is 2 times 19 gives you 38. And then our denominator here is just going to be a 1 because that was our leading coefficient. So those really are the zeros that we would want to try for. So you grab your graphing calculator. Calculator was being ornery there for a minute, so I went ahead and punched this in and came back to you here. So let's try Zoom 6 and see what we can see. And it takes a while. And we see that to the left of the y-axis we don't get one. But it really, really looks like 2 is a repeat 0. So I'm going to hit second table, second graph. And, ooh, that's way off. I'm going to hit table set. I'm going to start this at 0. That way I can see what I want to see in the table. I'm looking at 2. And I do notice that at 2 it is a 0. Now, it's quite possible, because if we go back and look at the graph, it's quite possible that that is a repeat 0. Remember, when they're tangent, when they bounce off, they could count twice. So what I would want to do is check out the 2, but check it out not just once synthetically, but twice synthetically, and see whether or not it works. So checking out that 2, going back to the coefficients of 1, 2, negative 11, negative 13, and 38. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and add. So pretty obviously 2 is a 0. But now remember, it's quite possible that it was a repeater. So I would try this again and see if I can get another 0 and keep working with it. So I bring the 1 down and then I multiply, and I add, and 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 I see, wait a minute, I was supposed to be able to stop right here. That was supposed to be a 0. Well, only if it is a repeat 0. It's not a repeat 0. It maybe looks like it in the window that we have it, but it's not. So only the 2 is going to work here so far. So 2 is a rational 0. Not because of the second time, but just the first. So what that tells me is there was another one there. It actually dipped below that x-axis, but I couldn't see it. So now, well, what on earth do we do? Well, we go on to C, and C says, hey, given that you found this out, write this in factored form. What would it look like? Okay, well, if we're using x minus k and we just found k is 2, that's going to be x minus 2. I don't want to lose my notation here. So f of x would equal x minus 2 times what? Well, that's what these were for. Those are our coefficients there. So constant x, x squared, x to the third. This would be x to the third plus 4x squared minus 3x minus 19. And that would be the best we could do with the factored form there. And then you say, okay, Cedar, you just said that's the best we could do. And now D says, go find that other one. Yeah, it does. So what we have to do is we have to use a graphing calculator because we can't factor x cubed plus 4x squared minus 3x minus 19. The only tools we have in our toolbox for that right now are going to be factoring by grouping, and that one is not factorable by grouping. So as we go back up here and take a look at D, it says approximate. Approximate. That's a big clue there. All of the irrational zeros of F. That other one's not rational, or we would have been able to find it. So now we're going to zoom box, and we're going to see just how close we can get in to finding that other 0. So what I want to do is bring Blinky into position. Remember with zoom box, he needs to be in that upper left-hand corner. I'm going to press enter, and then bring it down and to the right, forming the dimensions of that box. And then I press enter, and the screen will zoom in on that. So we're going to see that this is going to hit at our 2, and we're going to see, yeah, it does look like it goes below it, but not real clearly with this. So we're going to zoom box one more time and try to get an even better look at what is going on in this portion of the graph right here. So again, you're marking with enter that upper left-hand corner of your box. And then you are using your arrows to move down and to the right in the hopes, enter, that we will see that dip below the 2. And sure enough, we get a good look at it here. And we hit second trace once the calculator's done. Number 2. And we're going to move Blinky into position, and he needs to be under it to be to the left of it. And hit enter, and then go above the x-axis, hit enter again, and enter your guess. And Blinky says 2.0393773. So 3 decimal places, 2.039 would be our other 0. All right, so this little bugger here, 2.0390. All right, now E says, you know that, figure out how to write it in factored form again. All right, so we already know the x minus 2, that was done, that was taken care of. But now we've got this obnoxious 2.039. Well, how do I get the rest of it? Oh, good news. We get to synthetically divide with a nice little decimal here. So 2.039 is what we're going to use in the leftovers after we had our first 0 of 2 taken out, and that is right here. That's what we have to divide by that 2.039. So 1x cubed, 4x squared, negative 3x, negative 19, that is in standard form, which is exactly what we want. And now, usually the thing we love about synthetic is that the math is easy, but with this one, you'd probably grab a calculator, bring down your 1, do your multiplying, and then add. Multiply by 2.319, and yeah, here's where things just get kind of ugly. 12 point, I don't want to round too much at this point either, so 3165687. In fact, when I went through this originally, I didn't round anything at all. So we do that addition, 9.316568972. Multiply that by 2.309, 18.999. Oops, that looks like 19. Grab it. Which, of course, we should see as, wait a minute, that's super close to 19. So we said that was a 0. We know it's supposed to work. So we had our first 2 pieces, and the question was, what's going to go there? Well, now we know. F of x is going to be x minus 2. X minus 2.039, and now we have to write down, well, what on earth did we get from this mess? And I'm not going to be able to fit this here since I wrote so big, but this is what we had. So remainder constant x squared, so x squared plus, and now I'll go ahead and round to the 3 decimal places, 6.039, and that is x, and then we have plus 9.317, rounded to 3 decimal places. So x minus 2 times x minus 2.309 times x squared plus 6.039x plus 9.317. Whew! There it is. That's a lot of problem. And then the last one here, let f of x equal the quantity x plus 2 times the quantity x squared plus x minus 1 minus 3, which of the following statements is not true? So I started thinking about what they're really saying here. What they're saying is they took some polynomial and they divided it by x plus 2, and that gave them x squared plus x minus 1, and then they had this remainder of 3 over x plus 2. So let's go through and see what makes sense and what doesn't here. We're looking for the false one. A says the remainder when f of x is divided by x plus 2 is negative 3. Yep, absolutely it is. That's what it was. That's why it's there. B says the remainder when f of x is divided by x minus 2 is negative 3. Uh-oh. That's generally, I'm going to go with, hey, that's false. We'd always want to check all the other ones first is what I'm getting at. Right now, I definitely am going to put false there because we were dividing by x plus 2, not x minus 2. But keep in the back of your mind that it could be one of those best answer situations, so we just keep going on any ACT or MCA. C says the remainder when f of x is divided by x squared plus x minus 1 is negative 3. Well, yeah, because it doesn't matter if this is your divisor or this is your divisor, you still are going to have this remainder. So this one is also true for C. D says x plus 2 is not a factor of f of x. Well, no, it had a remainder. I mean, remember that our remainder has to come out to be 0 to be a factor, so this one is also true. And then E says f of x is not evenly divisible by x plus 2. Again, we had a remainder. That is absolutely true. It is not evenly divisible. So it definitely is, in any situation, best answer or not. B is the statement that is not true.